Okay, I thought to take a look at an application to using inequalities in the real world, we take a look at me and my second job, as sales clerk, of course. So, I really pride myself on that sales clerk job. It means a lot to me. And, let me tell you the two options that I have, the two pay options I have for weekly pay. One of them is that I get paid $100 a week. Now, for me, that's for an educator, as you may know, that's good money. And there's a bonus. For every sale I make, I get $8. So $8 per sale plus $100 a week. Pretty good deal. But an even better deal is the following. They're willing to pay me, same job, by the way, same job. They're willing to pay me $250 a week. Look at that. That is a lot of money, like a lot more than double this. But then only give me $3.50 per sale. And the question is, which should I pick? Well, the important thing to know is what kind of salesperson am I and how much am I going to sell? So the question I want to pose right now is, how many sales per week must I make so that plan A would actually yield the higher paycheck? Now think about this. Even though I'm getting $250 a week here, and here I'm only getting $100, since I'm getting $8 per sale here and only $3.50 per sale here, it's clear that if I make a ton of sales, this amount of money will start to accrue, and I may actually grow over a salary over here. And I want to know, where is that point? What's the smallest number of sales I have to make so that plan A, the $100 a week plus $8 bonus per sale, is actually the better deal? I make more money. So I want to know, when is this thing bigger than this thing? So actually, that's an inequality I've got to set up. I've got to solve an inequality where this thing is greater than that thing and figure out how many sales we have. Okay, so let's take a look and see if we can actually do that. I'm going to take all this. I'm not going to throw this. I'll throw these 50 cents. This actually goes to one of our camera people. Very good, quite on both. Okay, but the cash I will not throw. This I will pocket myself because you can't trust anyone. Okay, but now here we go. Let's take a look and see how you'd play this out. So let's suppose that the number of sales that I actually have is S. So let's let S equal the number of sales I make per week. We're only looking at this weekly. Okay, then with plan A, in fact, I'll write them, you can see they're all over here. At plan A, what happens? Plan A, I get $100 for the week plus $8 for each sale. So how much would I make in 1 week? Well, I'd get that $100, lump check, plus I'd get $8 for every sale. And if I make S sales, then I'd be getting 8 times S dollars. So this is my total for plan A. That's salary plan A. What would be my total for the exact same week under salary plan B? Now look over there. There I get $250, one lump sum, plus the bonus is only, though, $3.50 per sale. So that would be 3.5 or 3.50 times the number of sales I make. And the question that I pose to you is, how many sales would I have to make so that plan A is actually more attractive, or more lucrative, I should say, than plan B? So what I want to know is, when does this number exceed that number? Okay? So now there's an inequality that I want to solve. So we set up the real world problem. I can take all these things off now, thank goodness. And now we can actually get down and see if we can solve this using math. So what I want to do is solve this inequality. So let's see. What I'll do is I'll try to get all the s's and variables on one side and all the constants over on the other. If I bring this 3.5s over to the other side, I would subtract it. Sign wouldn't change. And I would see what? I would see 100 plus. And if I take 8s and subtract off 3.5s, that would leave me with 4.5s. And that would be greater than 250. You see how I did that? I just subtracted 3.5s from both sides. When I do that on the right, they cancel. When I do that on the left, 8s minus 3.5s gives me 4.5s. Now I'll take this 100 and bring it over to this side. So I subtract 100, and I see 4.5s is greater than 150. If I take 250 and subtract off 100, I see 150. And then to solve for s, I have to divide by 4.5. So if I divide both sides by 4.5, sort of running out of room here on my screen, 4.5. Do I switch the signs? Absolutely not, because 4.5 is positive. So what I would see is S is greater than 150 divided by 4.5. And if we plug that into a calculator, what we see is this is 33 1/3. So S, which is the number of sales I make, has to exceed 33 1/3. So what's the smallest number of sales that I could make that would exceed 33 1/3? The answer is 34 sales. So if I make 34 sales or more, then I know plan A is the more lucrative plan for me. I'll make more money. However, if I make 33 sales or under, then I know I'd make more money on plan B. So the question was, how many sales should I make in order to have plan A be the most lucrative? The answer is 34 sales or greater. So 34, 35, 36, all the way out to infinity. In fact, if I make infinitely many sales, I'd be so rich I wouldn't be talking to you right now. Anyway, there's a great application of using inequalities to solve a real-world problem. Enjoy.